I'm here and looking at this simulation. Now, you can see that there's a couple things going on here. Um, I have here a compression wave. So you can see the little molecules and they're moving back and forth, and the wave is moving forward. So we have a longitudinal wave. But I also, for our purposes, I asked to place a graph of a transverse wave on top of it. Now, for now, you could ignore the rope or the transverse wave that's moving there. I just placed it there so that we can think and look at some points. So I'm going to play with the amplitude of this wave. So this is low amplitude. This is 0.5 centimeters is the amplitude. And check out how these molecules, these green molecules look. Now I'm going to increase the amplitude. Maybe you're thinking, oh my God, this is hard to see. And that's okay because I took screenshots that we're going to focus in on. So here are my screenshots. And let's check out, this is an amplitude of 2 centimeters. So this is high amplitude. And let's look at what's going on at our peaks, at our compressions. So here's a compression. Look at all these molecules here. Now, let's look at a refraction. Look at all these molecules. I can tell there's a refraction also because, again, I put this transverse wave on top of it to kind of help us, and this is a trough. So here's a refraction. There's not many molecules here, but there are tons of molecules here. There's tons of molecules compressed here when I have high amplitude. Again, here goes another trough, a refraction. It doesn't have many molecules here. Now let's lower the amplitude and see how this changes. So I lower the amplitude. Okay. Here's my compression. You can see the molecules, and you could also see the peak on the transverse wave that I put on top of it. Here's the compression. Here's my refraction. Hopefully you're noticing it's hard to tell the difference between where there's a compression and where there's a refraction. So again, here's the one with 2 centimeter amplitude. You can see where this is like really dense. The molecules are super compressed. There's tons of molecules here, not so much here. That's with high amplitude. With low amplitude, the compression is hard to see. The density at the compression and the density of molecules at the refraction seem about the same. So here's the idea. If the amplitude is great, then we're going to have a lot of molecules in the compression. So if our wave, our longitudinal wave has a is really big, there's going to be a lot of molecules squished into the compression. Whereas if the amplitude is low, the air molecules will not be that compact in the compression.